This is section 5.3. So if you recall, in 5.1 we learned how to solve quadratic equations, quadratic meaning they're square terms. We solved by factoring. And then in in section 2, we just kind of did some applications of that same thing. So we were still solving by factoring. So for our first example, let's kind of take one step back and just practice the solve by factoring method. So in this case, it's already set equal to 0. So if I'm going to factor, I have 3 terms. So I'm thinking trial and error. Okay, I know I have to have different signs. And in order to multiply and be 2x squared, it has to be 2x and x. Okay, to multiply to be 5, it looks like I can either, I need a 5 and a 1, I can put them in whichever parenthesis. All right, so I'll try the 5 here and the 1 here. So I have to check it. Let's see, on the outer, I'm going to have negative 2x. And on the inner, I'm going to have 5x. That's not going to work, right? That's not going to give me the 1x in the middle, okay? So let's toss that. The only other option is to switch the 5 and the 1. So I'll switch the 5 and the 1. I'll put the 1 over here with the 2. And the 5 over here. But again, still not a guarantee. I still have to check it. So on the outer, I'm going to have negative 10. And on the inner, I'm going to have 1x. That does not give me the 1x I need in the middle. And that's my only option. There's no other options for factoring. So what that means is this cannot be factored. There are some quadratics. In fact, there's a lot of quadratics out there that cannot be factored. You just haven't seen them because we've made sure that all the ones that you're trying to do actually work out. All right, so this cannot be factored. So let's put that down. Cannot be factored. Well, if it cannot be factored, that means it cannot be solved by factoring. So does that mean there's no solution? No. That means if it cannot be factored, you need another method to solve. Another method. Okay? And that other method is called the quadratic formula. Okay. So the quadratic formula says this. If you have a quadratic, meaning you have an x squared term, and you've got some, let's see here. So you've got your x squared term, could be any number in front. You've got your x term, could be any number in front. Whatever you're adding or subtracting, set equal to 0. So a, b, and c could be any number. If I'm comparing it to the one that I was just looking at up here, the a is the 2, because the a is the number in front of the x squared. The b would be a 1, right, because there's an implied 1 there. And the c would be the negative 5. Okay, so this just means it works for any equation. So if you have any equation that has a squared term in it, then in order to solve, it's always going to come out to be this way. You're going to get x equals, because remember, solving means you're finding what x is. So x is always going to equal, and here's the kind of big, ugly formula. So it's a big, giant fraction. On the top, it's going to be the opposite of b. So if b was negative, then this would be a positive number, and vice versa. So it's negative b plus or minus. You might be saying plus or minus. Well, one equation is if it's a plus all the way, that gives you an answer. And then the other equation is if it's a minus all the way across, that gives you a different answer. Because remember, when we solved by factoring, didn't we oftentimes have 2 or more solutions? So the same thing is true here. You have 2 or more solutions. We're just writing it as one formula. So let me finish out the formula. Negative b plus or minus big giant square root b squared minus 4 times a times c. Notice all of that is under the square root. All of that is in the numerator, the big fraction, all over 2 times a. So this is a crazy, ugly formula. I could show you exactly where it comes from, which I'm sure you don't care. But this will always work. And it looks ugly, but all you're doing is plugging in numbers for a, b, and c. Okay, so here's how it works. Let's look here at letter A. So first of all, in order to use the quadratic formula, you need to make sure, just as in when you solve by factoring, you need to make sure it's set equal to 0, because this formula is based on an equation that's set equal to 0. So the first thing I need to do is set equal to 0. And it doesn't matter which side I have the 0 on. I don't know why. Most people tend to like it on the right side, so I'm going to do that. So I'm going to subtract 2x, subtract 1. So I'm going to have here, let's see, x squared minus 2x minus 1. And that way it's going to equal 0. So that means we need to identify the a, b, and c. So the a is right here. The number for the x squared is 1. So the a is 1. Remember, the b is the number right here in front of the x. So the b is negative 2. And the c is always this number over here. So the c is negative 1. Okay, so now that we've identified the a, b, and c, I'm just going to start plugging into that formula. Okay, so my formula is this. I'm going to say x equals, okay, so I know it's going to be a big giant fraction. On the top, I need the opposite of b. Well, b is negative 2, so this is going to be positive 2 plus or minus. I'm just filling into the formula. Big giant square root. B squared, so b is negative 2, so negative 2 squared is 4. There's my b squared, minus 4 times the a number, which was 1, times the c number, which was negative 1. I'm just kind of putting them in parentheses there. I'll do the multiplication in a minute. And then it's all over 2 times a. Well, if a is 1, then 2 times a is just going to be 2. Okay, so the hardest part about using this, filling in is not hard. The hardest part is not doing something stupid when you simplify. Like, for example, don't think that you can just go in and cancel those 2's. You can't do that. You can't cancel those numbers if that top number is a part of addition and subtraction. So let's simplify underneath the square root. Okay, if I simplify underneath the square root, think order of operations. So I'm going to have 2 plus or minus the square root of, so I can't say 4 minus 4 because according to order of operations, the first thing I have to do is this multiplication. So 4 times 1 is just 4, so this is going to turn into a 4 plus 4 all over 2. So I've got 2 plus or minus square root of 8 over 2. Okay, so I have solved for x. This is my x equals, but it doesn't look like anything nice and neat. So let's use our calculator to simplify beyond here. So if it's a plus, all right, let's think about if it's 2 plus square root of 8 over 2. And no, you can't just cancel those 2's. Then on my calculator, let's just type that in. Let's just put in a fraction. And then on the top, I'm going to put 2 plus square root of 8. And then on the bottom, 2. All right, if that's the case, my answer is 2.414, blah, blah, blah. So remember, we always do 3 decimal places. So that's going to be 2.414. So x equals 2.414. That's one option. But then the other option is, what if that had been a minus? Right? If that had been a minus, then we're going to have, let's go to our calculator. And what you could do is, instead of retyping it, you could do a copy and paste and just go back and change that plus into a minus. So if that's a minus, then my answer is negative 0.414. So negative 0.414. And no wonder I couldn't factor it, because I never would have thought to, come up with 2.414 or negative 0.414. So I still had, multiple solutions because of the plus or minus. Okay, so how much of this would I expect you to show versus how much on the calculator? Well, I definitely want to see the setup, and I want to see you simplify the square root. Then you can put everything in the calculator. Okay, so let's look at letter B. Whether I'm going to factor or use the quadratic formula, no matter what, the first thing I'm going to have to do is set equal to 0. So let's set equal to 0. So the equation I'm really looking at here is 3x squared. If I subtract the 10x, I'm going to have minus 12x. If I subtract the 1, I'm going to have plus 4. So in this case, since it specifically says to solve using the quadratic formula, that's what I'm going to do. Now, you don't have to write out down the side like we did up here, you know, labeling A, B, and C. If you want to, that's fine, because I know this is my A, right? The B is in front of the X, and the C is over here. So if I set up my equation, X equals, so the opposite of B is going to be positive 12 plus or minus square root of, all right, B squared is going to be 144 minus 4 times A times C all over 2 times A would be 6. Okay, so I've got 12 plus or minus, let's do the simplifying inside the square root. So again, you can put that in your calculator. You can put in the 144 minus 4 times 3 times 4. Let me put that in. 144, come on thing. Let's go over here so you can kind of see. Here we go. We're trying to figure out what is 144 minus 4 times 3 times 4. I'm just working with the stuff under the square root, right? So under the square root, I'm going to have 96. So plus or minus the square root of 96 all over 6. Okay, and so now when I am simplifying, let's do the plus. If it had been a plus, 12 plus the square root of 96, we are going to have, so remember this is a fraction. We want on the top 12 plus the square root of 96, and on the bottom we have 6. So if it's a plus, 3.633 if we round correctly. But if it had been a minus, let me highlight here, if it had been a minus, so again, instead of retyping it, I like to just go up and do a copy and paste, and then go back and change that plus to a minus. Make sure you change it to a minus and not a negative. So 0.367. So the two possible solutions right there. Okay, on this one, we're going to have x squared plus 6x plus 13. Now, it seems like, you know, we're doing an awful lot of repetition of the same thing, but a subtlety kind of happens here on letter C. And let me show you what that is. So if I set up my quadratic formula, I'm going to say x equals, so this case b is positive 6, so the opposite of b is going to be negative 6 plus or minus the square root of, so b squared is 36, b squared minus 4 times a is 1 times c is 13 all over 2a, so 2 times 1 is 2. Okay, and if I simplify, I'm going to have negative 6 plus or minus. Let's figure out what's under that square root. So we've got 36, right? We've got 36 minus 4 times 13, which actually comes out to be, under the square root, I have a negative 40. So negative 40 all over 2. Now let me show you what happens. I mean, what do we do when we have a square root of a negative? Do you remember in the past we've said we don't do square roots of negatives? Let me just show you on the calculator what happens. If I say the square root of negative 40, I get an error. And notice what it says: in real mode, all calculators must result in a real number. So what that means is this is not a real number. So if you have a square root under a negative, that means it's not a real solution. So we're going to say here, no real solutions. Make sure you highlight that word real. No real solutions. Because there aren't real solutions. So what's the opposite of something that's real? Look at the next page. It's imaginary. Okay, So you have no real solutions, but you might have what we call imaginary solutions. So here's where we go into something really weird and strange you've never seen before. So in math, when you first learn about all the different kinds of numbers, and we're not going to really go there, you first learn about all the really different kinds of numbers. You think about, there's like this group of numbers, and we call these all real numbers. Okay, these are all the real numbers. Now, you might have integers, right, which are like, positives and negatives. Just say positive, negative 10. You might have fractions, right, like say, 2/3. Those are considered real numbers. You might have decimals, and you might, 2/3 really is a decimal, but you might have a crazy decimal that like goes on forever, like, maybe it's 0.3217 ... just goes on forever, like a crazy ugly decimal. All of those are still considered real numbers. But then outside of that, there's something that we call the imaginary numbers. Okay, and we don't really do much with imaginary numbers in high school math, except what we're doing today, and that is to let you know that they exist. Okay, they exist, but it's a much more involved kind of level of a math system. So the only thing you really need to know about imaginary numbers as far as standardized tests is what we're going to kind of go through today. Okay, so the way we handle these imaginary numbers, which occur when you have the square root of a negative, notice it says not all quadratics have real number solutions. That's what we're just saying. When this occurs, we have what are referred to as imaginary solutions. And what we do is we use the letter I. I stands for imaginary. And you'll notice whenever I write an I, it's going to be like this. I don't do it like this because I don't want you to get it confused with a 1. Okay, so just be careful. I don't care what you do, but if I ever confused one of your I's with a 1, then it's wrong. Okay, and they're defined as this. Square root of negative 1 equals I. Now, all that means is if you have a negative under a square root, you put an I. So if I have, let's kind of write this down here. If I said, what is the square root of negative 4? You'd say, well, the square root of 4 is 2, but because there was a negative under the square root, I would say the answer is 2i. Or if I said, what is the square root of negative 9? Well, I know the square root of 9 is 3, but because it was the square root of a negative, you would say 3, but it's imaginary. So you get the idea. I could say, what's the square root of negative 144? And you would say 12i. Okay? So let's look down here at number 1. Now, what if it's the square root of 24? Well, okay, so what if, all right, trying to get rid of this thing. What if we're trying to simplify number 1 here, square root of negative 24? In other words, what if the square root doesn't come out nice and neat? Well, the fact that there's a negative means I know there's going to be an I out in front, and so now I'm done thinking about that negative. So now, channel your Algebra 1 and geometry. If I want to simplify square root of negative 24, or just square root of 24, let's start thinking about what will multiply to be 24. So it doesn't matter what you start with. I could think about a 6 and 4. And maybe at that point, you would recognize that the square root of 4 is a nice, neat square number. So you could say, well, the square root of 4 is 2. So that 2 comes out here with the I that was out there. And since that 6 is not a nice, neat square root, that 6 has to stay under the radical. So you may remember back in geometry simplifying these square roots where some of them come on the outside and some of them stay on the inside. Okay, so let's look at negative 40. So the fact that it's negative means there's going to be an I on the outside. And so now I just start thinking about how can I simplify 40. Now, I know some of you would say 4 times 10, but I want to show you something. Let's say I thought about 8 times 5, because it does not matter. If I first of all think of 8 times 5, well, neither of those are nice, neat square numbers, so nothing's going to come out, but that's okay. So keep going. So let's simplify the 8. The 8 would be 2 times 4, and then can't do anything with the 5. I'll just leave it a 5. So now you might recognize, well, the square root of 4 is 2. So because of that 4, I'm going to have a 2 on the outside. But because neither the 2 nor the 5 are nice square numbers, they have to stay on the inside. But instead of leaving it on the inside as 2 times 5, I'm going to go ahead and multiply them back together and say square root of 10. So there's my simplified answer. So let's go one more. If I simplify the square root of negative 75, well, because of the negative, I'm going to bring out an I. And then to simplify the square root of 75, let's think of that as 25 times 3. So hopefully you notice there's a square root of 25. That's just going to be 5. 3 is not a nice, neat square root, so it stays under. And there's my simplified answer. So even though we now have a way of simplifying if there's a negative under the square root, that's not to say that that's a real solution. It's still an imaginary number. It's just our way of simplifying. And quite honestly, the only time that that's really going to come up for you is probably going to be on standardized tests. Okay, let's take a look at number 5. So how do I handle it if I'm multiplying 2 radicals or 2 square roots? Well, multiplying, you can just put them together under the same square root. So I can think of this as one big giant square root of, let's see here, negative 36 and negative 16 just being multiplied under there. So hopefully you would agree that when you multiply the negative times the negative, those are going to cancel. It's just going to be positive. But instead of actually doing the multiplication and figuring out what 36 times 16 is, since it's being multiplied, at this point I could just say, well, hey, look, I know that the square root of 36 is 6, so 6 can come to the outside. It's kind of like this up here where you just had numbers being multiplied under the radical. And I know that the square root of 16 is 4, so I can just bring that out. And notice there's nothing left in the radical. That means there is no radical left. So the only answer here is that 24. Okay. Okay, so that is section 5.3, which is about the quadratic formula, and then an introduction to imaginary numbers so that you can help show your solution to a quadratic formula problem that might not be a real solution. You can put the little I in there to show that it's an imaginary solution. So we will do a 5.3b video that will pick up with the rest of imaginary numbers and finish this section.